Hello everyone, Professor Lohit here. Today we will see the lecture number 2 on payment design. So today we are going to see the CBR method or IRC 37 2001 method. This method, when you go for the designing the flexible payment of different components, here you are going to use the base of CBR. So depend upon the CBR value, you want to design the different thickness of the flexible payment. So as you see in the problem here, so how it goes, design the flexible payment for the full design life of 15 years for the following data by using IRC 37 2001. We already got updated in 2012, but as per your syllabus we got the IRC 37 2001 edition. So according to that, we have to refer the code IRC 37 2001. So here it gives the guidelines to how to design the payment, flexible payment by using the CBR. Okay, this is the guidelines where you can design here up to 30 million standard excels at the curve. So MS is nothing but million standard excels. Okay, here different guidelines you can find how to design the approach and the criteria, what's the traffic and generally. So I will explain you here what required to solve the problem. So as we know that the standard excels in India, it is 8160 kg. For estimating what design traffic, we require is all the initial traffic conditions, okay, after the construction or before constructions, that is expressed in CVPD, that is commercial vehicles per day, traffic growth rate during the design life in percentage, how much growth per year is happening, 7%, 6%, 10%, that is what the traffic growth rate. Design life for number of years, for any of the payment design for 5 years, 10 years, 15 years, that's the design life is all about. Then vehicle damage factor, obviously when the vehicles, like a damage factor is a multiplier to convert what number of commercial vehicles for different excel loads and excel configuration to the number of standard excels, like load repetitions. It defined as the equivalent number of standard excels per commercial vehicles. So this vehicle damage factor varies with the vehicle excel configuration, excel load, terrain, type of road, forms region to region. Okay, this is how it's going to vary. So here you come across the traffic growth. If they not provide any of the traffic growth, so according to this, you can take it as a 7.5%. Here we have the design life. So design life for the national highways, state highways, we have the design life as, for national highways and state highways we have the design life of 15 years. Expressway and urban roads, we take it as a 20 years. For other categories of, we take it to 10 to 15 years. Clear? This is a VDF. The important is you have to note this. Okay, initial traffic volume in terms of the commercial vehicles, if you are having 0 to 150, the terrain is rolling or plain, you take it as 1.5. If it is hilly, you take it as a 0.5. So 150 to 1500, we take 3.5 in case of plain and rolling. In case of the hilly, we take it as a 1.5. If it's more than 1500, we take 4.5 in case of rolling and plain terrain, and hilly we take as a 2.5. And this is the distribution of commercial traffic over the carriageway. If it is single carriageway, it is a 2-lane carriageway, and if it is 4-lane, a single carriageway, take it as a 75% of the number of commercial vehicles. Okay, if it's 4-lane, it's going to be 40%. That is single carriageway. If dual carriageway, okay, if a 2-lane would take it as 75%, and if it is 4, so for dual 3-lane carriageway and dual 4-lane carriageway, take it as 60 and 45 respectively. Clear? Okay, this is we take it as according to the what category of the road you want to build. So for computation of the design traffic, we have this formula. N is nothing but 365 into 1 plus r raised to n minus 1 divided by r into a into d into f. Okay, where n is nothing but the cumulative number of standard excels carried for the design in terms of million standard excels. Always the n value is going to be in million standard axles. Okay, if you get the any of the values, you have to divide for the 1 million. So you get the 1 million standard axles. You see it in a problem. A is nothing but initial traffic in the year of the completion of construction in terms of the number of commercial vehicles per day. Okay, if something it consuming the what you call the number of years between like last count of the year or the completion of the construction, that time you have to find the p value there. Okay, we see it in the problem. D is nothing but distribution lane, as I explained, like for dual lane or two-way traffic lane or two-way single account that you want to take. Vehicle difference factor, it's all depend upon the how much CVPD. N is nothing but design life, how much you are going to choose it. R is nothing but the growth rate. If they not provided in the question, then you have to take it as a 7.5% as a standard growth rate per year. Clear? Okay. If something A is the initial traffic in the completion of the construction, if it is a prior to construction, take it, then in those conditions you have to find this A. A is given by P into 1 plus R is to X. X is nothing but here the number of construction period. Something taken 2 years or 1 year as a construction period, take that as a X. Clear? By seeing that, we find the A that we are going to use it here next. Clear? Okay, we solve one problem on this, we get to know that. Clear? Here we have the graph, we can call it as a figure, the pavement thickness design for a traffic 1 to 10 MSA. Then you are going to refer this chart. Okay, in other page of the code book, in figure 2, we have the same pavement thickness design criteria for 10 to 150 MSA. This chart is for 1 to 10 MSA. If you get the value, then if you get the traffic value in between 10 to 150 ms, then we are going to refer this. This we called as a plate 1 values and this we called as a plate 2 value. Okay, that is on a x axis we got the design traffic, on y axis we got the total thickness of the pavement, and here we find the what are the lines are running, these we called as the CBR values. So depend upon whatever the MSA values or traffic value you getting, that we coincide with the whatever the respective CBR value of the soil we having. Then we see on a y axis what the thickness of pavement supposed to be. Okay, same it goes with the here too. Clear? This is in a code book on page number 8 and 9. Next, here we have the catalog of a plate 1 where the range of the MS is 1 to 10 MSA. Okay, here you have the cumulative traffic in a MSA like 6, 7, 8 or something. What the thickness of the pavement supposed to be, what your bituminous surface course in that varying course, binder course, what the thickness, what the layer, and here we have the granular base and the granular subbase. This is for the CBR with having the 2%. Clear? And here we have the for 3% and 4% here. Same way, depend upon the MSA, it is going to vary. Here we call it as a plate 1 because its range is for only 1 to 10 MSA. Clear? For that we have the different thickness now. Which layer, what are the different composition you are going to have. And if you go for the further, in plate 2, this is a plate 2, this is a plate 1, okay, which ranges from 1 to 10 MSA, and here plate 2 which ranges from 10 to 150 MSA. Clear? Here if it is exceed, then we are going to have this 10 to 150 whatever range. According to that, we could, here you also have the 2%, 3%, 4%. This is how it goes up to the 10%. According to that, we are going to choose the what's the composition is supposed to be. Clear? We solve one problem on this. Let us go through this whole code book again. Okay, this is the problem. Design the flexible pavement of for a full design life of 15 years for the following data as per IRC 37/2001. It has a 2-lane carriageway and traffic at the present is going to be 220 So 2200 CVPD, that is commercial vehicle per day. Growth of the traffic is 8%. Vehicle damage factor taken is 6.5%. It is having the construction period of 2 years. In that we got the present traffic. It's not a traffic after the construction, the initial traffic. Okay, it is a present traffic in the sense before the construction. So in construction consuming 2 years means we have to know, I have to know the after 2 years what's the traffic is, initial traffic is supposed to be. For that I have going to have the 8% growth. Clear? And CBR of the soil is 4%. Sometimes they not given you construction period, then you take directly this value as a A. Okay, I will copy this formula from the code book, that is here. Computing the design traffic. Okay, that is n is equal to 365 into 1 plus r raised to n minus 1 divided by r into a into d into f. Clear? So here they given you the traffic before constructions. So after in 2 years again the traffic some growth will going to happen. So for that I am going to find the A here. A is nothing but, okay, that's formula, it is given here in the code book. P 1 plus r raised to x. X is nothing but number of years between the last count and the year after the completion of the construction. So P 1 plus r raised to x, where it's going to be 2200 1 plus growth rate is 8% in the sense 0.08. How many years? 2 years. So if I calculate this, it's going to be somewhere 2566 CVPD. This is my A. If they are not given any construction period, then you take directly that as a A. Clear? So other than that, what all I required? I required the design life, yeah, that is n. N they given it as a 15 years. Okay, they given you the growth rate as a 8%, that is nothing but 0.08. Okay, I got the A here. Then what is the distribution? They got given you the VDF, vehicle damage factor 6.5. If not given, you have to go for the table here. According to that, you are going to choose the VDF on page number 12. So okay, only difficulty what you are getting here is what is the D? D is nothing but here. What is the D here? That is distribution factor. Let us check here. So they mentioned it's 2-lane single carriageway, then it's going to be 75% of the total number of commercial in both the direction. So 75% is nothing but 0.75. If it is 4-lane in a single carriageway, then you are going to take here. If it is dual 2-lane carriageway, then we are going to take is a 0.75%. That is what I explained you previously. So according to that, my D is going to be 0.75 for a 2-lane. If I input all this value, my N is going to be somewhere 123 into 10 raised to 6. Okay, if I divide by the 1 lakh, it is going to be what? 123 MSA. Million is nothing but 10 raised to 6, right? Okay, whatever the answer you get, if I divide it divide for the 10 raised to 6, that is going to be my, this is standard Excel only. Okay, if I divide with the 10 raised to 6, it's going to be million standard Excels, because all my charts works on a million standard Excels only. Okay, so now let us get into the chart. I have this two charts now. Which one I have to refer? I have to refer B. The reason is here, this chart shows in between 10 to 150 MSA, and here this chart is all about 1 to 10 MSA. So my value is 123, right? N value is 123. So it lies between 10 to 150. So I have to refer this. Clear? So this is the log scale. So 123 around somewhere here. For 123, what we're going to do, what's my CBR value is 4%. Where is 4%? This is the 4% line. This is a 3% line. This is the 2% line. This is a 5% line. I hope I am focusing it properly. You can see it. So 4% line is this one. So what I do here, hope it's clear now. This is a 4% line. So where my 123 ms is somewhere it comes here, goes here, where it cut, you see, check it here. Okay, so this curve is going to cut somewhere here. Okay, if I take it on a y-axis, it comes and hits somewhere here. Okay, this line is about 800 and this comes around here, means it's going to be 810 mm. That is going to be my thickness. Clear? So to find the composition, I have to go for the plate 2, which having the CBR 4%. This is how you have to refer the graph. 123 is something here. It goes here, we'll cut the 4% of the CBR. Then if I take it here, it comes around here on a y-axis. So that's going to be my 810 as a mm as a thickness, total thickness of my pavement. Okay, this is a plate 2. Range is 150 MSA, and this is a 4% CBR. So I'm going to find the compositions. As I see here, my value of 123 MSA lies in between 100 to 150. So I don't have 123 in the sense I have to interpolate in between the two values. If I interpolate, I am going to get somewhere 810 or thickness. Okay, you know how to do the interpolations. Have here as a 123 MSA. For that, I am going to find the what my thickness is supposed to be. Okay, that is going to be somewhere 810. You can check it. Here, the both the side it has a 50-50 in the sense I have to keep it as a 50 mm for the what BC, that is bituminous concrete. For DBM, again I have to give I have to interpolate here. Okay, if you have, then for GSB it's common. So whatever the MSC, whichever the MSC you are having, you have to give the minimum as a standard value as a base as 250 mm and sub base as something 330 mm. Here I do the interpolation. So how much you get, you can find the value here. Clear? So if you do the interpolation, then you have to draw the graph or a chart, you can say. The first layer is going to be obviously its sub base, okay, which has something 330 mm. Then have base which has 250 mm. Okay, then I have next is DBM around 180 or something. If you do the interpolation, you get the value. The next is BC layer, bituminous concrete, which is 50 mm. So all together it is going to be somewhere 810 mm. This is how you to solve the problem. Is it clear? So for practice in a codebook only, on the page number 48 and the 49, you have two problems to solve. Okay, that is for your assignment or homework, you can take it. Okay, on a codebook only, you have on a page number 48 and 49, you have two problems, solve it. Yeah, that's it from the today's class. Thank you for the patience.